Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are going to discussing one of the important problem from this unit. The problem based on Cauchy Euler Equation. Okay, so listen carefully. Very important problem. So repeated so many times in the examination. In the previous lecture, we discussed the general derivation of Cauchy Euler Equation, how we can derive in that general format, and also we discussed that nth order Cauchy Euler Equation. So now in this lecture we are going to discuss a problem based on that Cauchy Euler Equation. Those two lectures are very important, Amma. So observe carefully. Question: solve x square d square y by dx square minus x into dy by dx minus 3y equal to x square log x. Okay, so this is the second order Cauchy Euler equation. We have to find the general solution for this given equation. Okay, so first of all observe that solution given second order Cauchy Euler equation is x square d square y by dx square minus x into dy by dx minus 3y is equal to x square log x. So we are taking that equation number 1. Now to solve this Cauchy Euler second order differential equation, okay, for any order differential equation in this method, we have to assume a suitable function, okay, to substitute in place of variable. So that function is always x is equal to exponential function e power t. Okay, so you can take x is equal to e power z, you can take x is equal to e power y, or x is equal to e power t, or x is equal to e power k, but it is always on exponential format only. So in our procedure we are taking that x is equal to e power t. And observe given equation number 1, amma, given equation number 1. So what is the a suffix 2 value, amma? A suffix 2, a suffix 1, a suffix 0. What is the a suffix 2 value? A suffix 2 is equal to 1. And next constant, amma, a suffix 1 is equal to minus 1. Okay. Next a naught is equal to ikkada minus 3. So these are all constant values. When we discussed about the general derivation, where x square small x are the functions non-constant coefficients, but a suffix 2, a suffix 1, a suffix naught are the constant values, that is 1, minus 1 and minus 3. And this is that RHS Q of x value. Take x is equal to e power t. After taking the next step, apply logarithmic on both sides. Log x is equal to log of e power t. Okay. In the next step, this t value goes to the multiplication. You know very well. So log x is equal to small t. So okay, small t into here you will get log x is equal to, you will get another step, that is log x is equal to log e base e. Okay, log e base e. You know very well log e base e, that value log e base e value 1. So therefore directly t into 1 is nothing but small t only. So that's why we are writing log x is equal to small t. And from the derivation we discussed that capital D is equal to d by small dt. Okay, so capital D is equal to, from the derivation we discussed that d by dt. For this problem, so you have to take it is d suffix 1. D suffix 1 is equal to d by dt. Substituting these corresponding values in equation number 1, substitute x is equal to e power t, and substitute log x is equal to small t, and substitute d by dt is equal to d1 in equation number 1, then you will get amma. So when you substitute all those values, amma, in the derivation only I clearly explained, whenever you have the term amma, x square d square y by dx square, okay, in Cauchy Euler equation you should remember as d square y minus dy. If you take y common, d square minus d into y. Again if you take small d common, d into d minus 1 into y. In the general derivation I explained the same thing. In the problem also we are following the same thing, amma. Wherever you have x square into d square y by dx square, we are writing d1. Here we are taking d suffix 1. So therefore d suffix 1 into d suffix 1 minus 1, d suffix 1 square minus d suffix 1, in that format. So d suffix 1 into d suffix 1 minus 1. How you will get that value also I explained clearly in the previous lecture. Okay, so therefore minus next term amma x into dy by dx, x into dy by dx. So therefore that is the dy by dt value. X into dy by dx is equal to, it is a small dy by dt. So we can write that value d1 into y. So d1 into minus 3 into, in place of y amma, so we are writing that value y only. So they therefore take small y. Initially small y is there in this equation amma, so small y is there here also and here also. After that we are taking small y common. Okay, so direct step I wrote here d1 minus d1 into d1 minus 1 minus d1 minus 3 into y is equal to, in term x square. X square is there amma. If you write x square is equal to, what is the x value? E power t. E power t whole square means e power 2t. In place of x square, e power 2t. Log x is there. In place of log x, small t. So therefore now from that equation amma, so we can write multiply that d square value amma. So multiply with d1 square minus d1 and minus d1 as it is, minus 3 into y is equal to, so t into e power 2t. So therefore minus d1 you will get to minus 2d1. So therefore d1 square minus 2d1 minus 3 into y is equal to t into e power 2t. So therefore that is taking as equation number 2. Now here you can observe amma, it is also a linear differential equation of second order but with constant coefficients. Here coefficient nothing is there, d1 square coefficient is 1 and d suffix 1 coefficient is minus 2 and minus 3. Here all are the constant coefficients. It is a linear differential equation of order 2 with constant coefficients, that is called equation number 2. So therefore equation number 2 is a non-homogeneous linear differential equation with constant coefficients of the form f of d of 1 into y is equal to q of x. So the given Cauchy Euler equation we converted into linear differential equation of order 2 with constant coefficients amma. That is the general form. Now after converting amma, so you can compare given equation number 2 with that general formula f of d suffix 1 is equal to d suffix 1 whole square minus 2d1 minus 3 and RHS part q of x is equal to t into e power 2t. In unit 3 amma, we discussed very clearly that one of the method to find the solution of linear differential equation of constant coefficients, whenever you have that RHS value q of x value t into e power 2t, so that t into e power 2t comes under the type of e power ax into v amma, e power ax into v method. So where v is a function of small x, but here in place of small x we have the variable small t, where v is a function of small t. So small a is equal to, what is the value? 2. Small x is equal to small t and v is equal to t only. So therefore, so now to solve that equation number 2 amma, okay, so therefore the well known procedure, first we have to find that complementary function. Why? Because the general solution y is equal to yc plus yp na. So first we have to find the complementary function. Complementary function y suffix c is equal to, so first auxiliary equation from that f of d1, that is given by f of m is equal to 0. You know very well f of d1. So in that equation if you substitute m amma, so it will become the auxiliary equation. So from this d1 square minus 2d1 minus 3 is there now. So in that equation m square minus 2m minus 3 is equal to 0. So find out the square root sum. So therefore if you multiply first term last term, 3m square will come. If you separate them, minus 3 1. So therefore m square minus 3 plus m minus 3 equal to 0. Take small m common from the first two terms and take plus 1 common from the last two terms. So if you take small m amma, m minus 3 will come. If you take plus 1, again m minus 3 will come equal to 0. Again take m minus 3 common amma, so then you will get m minus 3 into remaining values m plus 1. Here nothing is there ma, plus 1 will be there. Okay, so therefore అక్కడ ఏం లేదంటే మనం ఏమని చెప్తామంటే m plus 1 ఉందని చెప్పేస్తాం. సో therefore m plus 1 equal to 0. So therefore, first root to m suffix 1 I am taking minus 1. Why? Because if you apply that m1 m plus 1 is equal to 0, therefore m1 is equal to minus 1. If you substitute m minus 3 equal to 0, m suffix 2 is equal to 3. So here we have the roots are real numbers and two roots are different roots, distinct roots. Okay. Hence, the complementary function is y suffix c is equal to when roots are real numbers and distinct values. You know very well the function y is equal to c suffix 1 e power m1 into t plus c suffix 2 e power m suffix 2 into t. Two roots gabati. So m1 m2. Next y suffix c is equal to substitute m1 value minus 1 minus t is nothing but minus 1 into t plus c suffix 2 into e power m2 value. M2 is 3 into t. So therefore y suffix c is equal to c1 e power, substitute t value again. What is the t value? Log x. Okay, so therefore minus log x, minus t is equal to minus log x plus c suffix 2 into e power 3 into again t value log x. Since you know very well t is equal to log x. So therefore, and here you have coefficient of log is minus 1. Send that value to powers. You know very well y suffix c is equal to c1 into e power log x power minus 1 plus c suffix 2 into e power, same if you send this 3 value to powers, log x power 3. Now it converted into e power log f of x formula. So therefore it is equal to f of x. What is that f of x here? X power minus 1. Here what is that f of x? X power 3. So therefore y suffix c is equal to c1 x power minus 1 plus c2 x power minus 3. So simply we can get that complementary function. For the complementary function, the procedure is same. Okay, easy only. Now come to particular integral or particular solution. So particular solution we can indicate with y suffix p. Observe to find that particular solution. Observe that RHS part of equation number 2, that is y suffix p is equal to 1 by f of d1 into q of x. This is the general equation to find that particular solution. So y suffix p equal to, substitute the corresponding values. What is the f of d1 value? d1 square minus 2d1 minus 3 into q of x value, that is t into e power 2t. It is in this format where small a is equal to 2. We discussed just now. Okay, so therefore e power ax into v, that RHS value q of x is equal to e power ax into v format. So therefore whenever you have that q of x function in this format, y suffix p is equal to e power at write first, e power a of x write first, after that write 1 by f of d function, f of d into write small v value v. Okay, so therefore whenever you have e power ax into v function q of x value in this format, then y suffix p is equal to e power ax into 1 by f of d plus a, f of d plus a into small v. So this is the procedure, d plus a, d minus a, whatever depending upon the given constant value. Okay, so d minus a, actually d minus a. So therefore from that equation wherever you have d, so substitute to d minus a value, where a is the x coefficient of exponential function. So therefore y suffix p is equal to e power 2t 1 by, so f of d you have d1 square minus 2d1 minus 3 kada. So wherever you have d suffix 1, substitute to d minus d plus a. So that means d1 plus a. Here it is also d plus a. Sorry. So therefore d1 plus 2, a value 2 na, d1 plus 2 whole square minus 2 into d1 plus 2 minus 3 into v value small t. So therefore y suffix p is equal to e power 2t into, apply that a plus b whole square formula in the denominator. So therefore d1 square plus 4 into d1, remaining term multiply with minus 2 into d1 minus 2 into plus 2 minus 4 and minus 3 as it is into v small t. So therefore y suffix p is equal to e power 2t. Simplify So here you have plus 4 minus 4 will get cancelled. Okay, plus 4 d1 minus 2 d1 is equal to 2 d1 only. So therefore d1 square plus 2 d1 minus 3 into t. Now, so it is again in that algebraic format. Q of x is equal to small b into x power k format. Okay, so where what is the b value? Here b is equal to 1. B is equal to 1 and x power k is equal to t power 1 amma. So therefore again to simplify this value amma, take constant value out, take constant value in the denominator as a common. So therefore y suffix p exponential function as it is e power 2t 1 by, whenever you have that again that q of x value in this format b into x power k format, so the procedure will be in this format amma. Take a constant outside, you know very well, when you have q of x is equal to b into x power k, then y suffix p is equal to, from the denominator you have to take that constant value minus a naught value common, then you will get that function x. So therefore if you take constant value here is minus 3, take minus 3 common amma. If you take minus 3 common from the equation f of d, so 1 minus, in place of minus 3 you will get 1 amma, minus remaining two terms are there, d1 square minus 3, remaining two terms are there na. So therefore in those two terms if you take that minus 3 common, so d1 square plus 2d1 by 3 will come, including with minus, okay, into t. So therefore now it is in that 1 minus x format, 1 minus x. So send the term to numerator or make send to the term numerator, then it will become x power 1 minus x whole power minus 1 like that. So therefore e power 2t by minus 3 into, if you send the denominator value to numerator, it will become 1 minus d1 square plus 2d1 by 3 into whole power minus 1 into small t. Now it is in this format amma, you know very well that formula 1 plus 1 minus x whole power minus 1 from the binomial expansion. What is the formula? 1 plus x plus 2x 1 plus x plus x square, 1 plus x plus x square amma, 1 plus x square plus x cube plus up to so on. When you have minus here and in the power also minus, in formula all plus symbols will come. When you have 1 minus x, 1 plus x whole power minus 1 plus x minus x will minus x square plus x cube will come alternatively. Okay, so therefore now that second formula is not required amma, we required only first formula only. So therefore 1 minus x whole power minus 1 format, if you expand that that power value, if you expand this total value by using this formula, so therefore y suffix p is equal to minus e power 2t by 3 into 1 plus x square plus up to so on, okay, into small t. So ignore higher order derivative except to power 2 amma. So therefore y suffix p is equal to minus e power 2t by 3 is equal to 1 plus, just we are taking the first differentiation values, only first term x values, and here if you again apply that whole square formula you will get to d power 4 amma, d power 4 you will get, but the function is small t only na. Small t, if you apply that fourth derivative it will become 0, even the second derivative of small t is also 0, okay. So we can do up to first derivative. First derivative of small t is 1 with respect to t. Second derivative of t with respect to t is 0. Why? Because 1 into dy by dt is equal to 0 na. So therefore we are writing 1 plus x format into t. We are ignoring all the higher order terms amma. We are ignoring, why? Because if you apply the procedure all terms will become 0 only. So not required in this term only. So multiply with t amma. So 1 into t plus 1 by 3 into d square d1 square into t plus 2 by 3 into d1 into t. So therefore y suffix p is equal to minus e power 2t by 3 into t plus 1 by 3 into, okay, so d1 square into t is there. That means that 2 times derivative for that t with respect to t only. So first derivative of t is 1 amma, and second derivative of 1 is 0. Constant differentiation 0 na. So therefore that is the 0. Next plus 2 by 3 as it is d1 of t. Here d1 is nothing but d by small dt nama. With respect to small t only na, it will become 1. So therefore y suffix p is equal to minus e power 2t by 3 t plus 2 by 3 So therefore y suffix p is equal to, substitute small t value, small t is equal to log x. So therefore minus e power 2 into log x by 3. So therefore wherever you have small t, substitute log x plus 2 by 3. So y suffix p is equal to minus log, send this 2 value to power m as x. So therefore e power log x square by 3 into log x plus 2 by 3. So therefore y suffix p is equal to, so that value in that product amma, that e power log x square, e power log x square is there. So therefore it will become x square only. So therefore minus 1 by 3 into x square into log x plus 2 by 3. That is the particular integral value. In that particular integral amma, we used two methods. The first method is e power ax into v. After solving that method, we got b into x power k format. Again, we got that y suffix p value. Okay, so therefore, now equation number 4, general solution is given by, the general solution of equation number 1 is given by small y is equal to complementary function plus particular integral yc plus yp, that is equation number 5. Substituting equation number 3 and equation number 4 in equation number 5, then you will get small y is equal to c1 x power minus 1 plus c2 x power 3, that is the complementary function, minus 1 by 3 x square into log x plus 2 by 3, that is a particular integral. So the total RHS is general solution of the given Cauchy Euler equation of that order 2. Okay, so this is the total explanation. Just nothing amma. First given equation you have to convert into linear differential equation of constant terms. After that, the rest of the procedure you know very well from the methods of unit 3 we discussed very clearly. Just you have to convert the given differential equation into linear differential equation of constant by substituting the suitable function small x is equal to e power t. Okay, just remember carefully. Very important problem. This is the total explanation of this problem, Amma. I hope you understood this problem very well. In the next lecture, we are coming with the next method. So make a perfect practice. Prepare well. Until bye. Thank you.